tutorial, I'm going to go over exam number 14. Exam number 14 is based on mechanics, static electricity. Now, exam 15 going to be just like exam 14. So please pay attention. We should not take more than 14 minutes, 1 minute per problem. Problem 1, 2, and 3 has to do with Hooke's law, right? Let's start with problem 1. Let's zoom in. Problem 1. Okay. So problem 1, I have a spring. I have a box, 1.5 kilogram, held against this spring, 0.1 meter, and the spring has a K, spring constant, 1000 Newton meter. All right, I want you to find the velocity when the box is at equilibrium, right? The box is going to be at equilibrium. Okay, so what would be the velocity? All right, so a few things. First, oh, well, this is wood on wood. So wood on wood. What does that mean? Mu K is 0.3. First find the weight. Weight is what? mg. M is 1.5. Let's say 2.5. Okay, so 2.5 kilograms. So 2.5 times 10. So weight is 25 Newton. Good. So what is then normal force? Normal force is equal to weight. Okay. Speaking of normal force, you have to find the FF. FF is mu K Fn. Mu K for wood on wood is 0.3. And this is 25. So this is 7.5 Newton. Okay, so you want to find work done by friction. Work done by friction is FFD. Work done by friction is FF is 7.5 and D is 0.1. So work done by friction is 0.75. Now, what type of energy you have when it is 100% compressed? Potential energy. What is the potential energy? Due to spring, half kx squared. So potential energy is half k is 1000 and 0.1 squared. So potential energy is half 1000 0.01. So potential energy is 0.01 to 0 cancel, half 10. So potential energy is 5 joule. Now, is all the kinetic energy become, is all the kinetic energy, all the potential energy become kinetic energy? No. How much potential energy become kinetic energy? Well, this much. This is no longer true. This is not true because there is a friction. So this is not true. Only this is true. What does that mean? These become kinetic energy. So what is kinetic energy? Half mv squared is equal to PE is how much? 5 minus this is 0.75. So half mv squared is equal to 4.25. So mv squared is 8.4. So v squared is 8.4 divided by 2.5. Mass is 2.5, yeah. So v squared is 3.4. So v is 2. So what is the velocity at right here? It's 2. Very close to 2. We are rounding. Now, second problem is 100% same but easier. I give you something like this. Hold against a spring, and this is like, let's say, I don't know, mass. K is 20 Newton meter, and it's compressed against this spring for 0.1 meter. Now, as I said, like if you have a spring, right? This is 100% compressed. After 100% compressed, what happened? This is equilibrium. After equilibrium, what happened? This is 100% is stress. All right, right? Here delta x is 0. Here fs is kx. Here fs is kx. Right. So we are trying to find fs when it is compressed. So fs is 20 times 0.1, which is 2 Newton. All right. The third problem is a little bit interesting. The third problem is I'm going to keep the same problem, but I'm going to add the inclined plane with the Hooke's law. Okay, what do we mean? I will add an inclined plane with H, D, an angle. Spring has a constant, let's say 10,000 Newton meter. So mass 1 kilogram, 1 is a nice number, it's going to keep the math easy. And let's say this stress is 0.1 meter. Okay. What we try to find is the D, how long the incline is. Okay, so we're going to do one thing at a time. First, we're going to start with what type of energy you have here. Potential energy. Potential energy due to what? Due to spring, half kx squared. How much is that? Half k is 10,000 0.1 square. So PES is equal to half 10,000 0.01. So PES is equal to half this cancel 100. So PES is equal to 50 joule. Right now, try to understand at location A, right? What type of energy do we have? Well, kinetic energy. All the kinetic energy, all right, all the potential energy turn to kinetic energy at location A, and the kinetic energy is 0 at location B. What happened? From 50 to 49 to 48 to 47 to 1 to 0. All right, it doesn't 50 doesn't become 0 instantly. 50 gradually becomes 0, right, from location A to B. How can we write that? Well, we can write A is equal to B, or A is equal to A to B. We can definitely write A is 50. B, A to B, we also can write 50, A to B, if you add all the point, right? Well, that's what it means. So is 49, 48, 47, okay. So yeah, it loses. All right. Okay, so how can we rewrite this? Let's try to understand what's going on actually. Then you're probably going to be better off. How many what is responsible for the box to send in the location B, kinetic energy? How many factors slowing it down? Two factors, WF and WG parallel. Okay, so what does that mean? 50 is equal to WF plus WG parallel. So 50 is equal to WF. WF has a name, mu mg cosine theta d. WG is mg sine theta d. All right, so 50 mgd is the common factor. You have cosine theta, mu cosine theta plus sine theta. All right, so 50 is equal to mgd. Mu is this is steel on steel 0.57. Steel on steel. What does that mean? This is steel, surface is steel. So mu k is 0.57. So this is 0.57 times cosine 30 plus sine 30. So 50 is equal to mgd. 0.57 times cosine 30 is 0.87. 0.87 plus 0.5, sine 30 is 0.5. So 50 is equal to mgd is equal to 0.5 plus 0.5. So 50 is equal to mgd 1. Voila, that's the nicest number you can imagine. So mgd is equal to 50. M is 1, so gd is equal to 50. So d is equal to 50 over g. So d is equal to 5. So 5 meter. So what is the d? D is 5 meter long. Okay, next problem. Next problem we're gonna be thinking of. Let me see. What is the next problem? Next problem is let's say you have y-axis Okay, so this is y, this is plate 1, this is x-axis, this is plate 2. Okay, plate 1 is positively charged, plate 2 is negatively charged. That means there is a field from positive to negative. Let's say the field is 10 raised to negative 2. Let's say there is the electron moves to 20 meters per second at velocity vx direction for 4 meters at location here. So let's say q is, this is negative, so q is, let's say 1 coulomb, so 10 raised to negative 6. Let's say mass is 10 raised to negative 10. Okay, great. Now at let's first find the acceleration. What is the acceleration of this one? By the way, the force would be this direction. This is force. All right. So first thing first, we're gonna find the x force or acceleration. Maybe acceleration. Acceleration is Newton's second law, F equal F over m. So acceleration is E q over m. So E is 10 raised to negative 2. Q is 10 raised to negative 6. M is 10 raised to negative 10. So acceleration is 100 meter per second square. Now, velocity is distance over time. Velocity is distance over time. This formula is only true at the x direction. Y direction, this is not true. X direction, acceleration due to gravity is 0. That's where it is true. So we're going to write, make it obvious. So then we're going to say that t is equal to vx over dx. So t is equal to L over dx. So t is equal to L is 4 and dx L over d, not dx, L over vx. T is dx over vx. So L over vx. Vx is 20. So t is 0.2. Good. Second, SI unit is important. Now, Vf is equal to Vi plus At. At what direction? This is also true at y direction. Why is that? X direction, acceleration is 0. Therefore, this must be at the y direction. Okay, what is VIY here? 0. What is VIY here? What is VY, not VIY? Alright, at right here, Vx is 20. Vx does not change. It's because why? We have acceleration due to gravity at the x direction is 0. Now, what is the location of this electron at 4 meters? Electron is now here, very close to the plate number 1. Good. So, this is 0 over here. So, Vfy is equal to, this is at 100, this is 0.2. So, Vfy is 20. Now, we're going to find the speed when the object is here. Okay, so now we know that c squared is equal to a squared plus b squared. So, Vxy squared is equal to Vx squared plus Vy squared. What does that mean? This means the speed. 20 squared plus 20 squared. So the speed is equal to 800. So speed is equal to 28.28. Okay, so this is the answer. Now let's go to the next problem. Next problem is, if you have, this is momentum and conservation of energy. Number 5. Number 5, momentum and conservation. Why is that? Is because let's say you have a bullet moving with which is 5 gram, and now there is a block which is 1 kilogram, and there is let's make few scenario, and this height is let's say height is 5 centimeter. First thing, we're going to convert this everything to SI unit. So this one going to be 0.005 kilogram, this one is 0.05 meter. Divide by 100, divide by 1000. How many scenarios I give you? 4 scenarios. Out of this 4 scenario, how many scenario the bullet is inside the block? Only 2 scenarios. Bullet is inside the block, bullet is inside the block. Out of this 4 scenario, how many scenario you have a velocity more than 0? Only 2 scenario. Velocity is more than 0, and velocity is more than 0. Okay, velocity is 0 over here, velocity is 0 over here. Okay, So now, which scenario out of this four scenario we are trying to find the velocity? Well, scenario 3. Speaking of scenario 3, how can we are trying to find the velocity here, this one. Okay, how can you convert this scenario to an equation? Well, it's very easy, KE. How can you convert this one to an equation? Well, it's very easy, PE. KE is half mv squared, PE is mgh. So you have mm cancel, so v squared is equal to 2gh. So ve is equal to, v squared is equal to 2 times 10 times 0.5. And that gives you 0.05, right? And that gives you velocity is, velocity is 1, okay? Square root of 1, which is 1. All right, great. That's all you need to find. Now, the next problem we're going to do is, let's say, 3, 4, 5, number 6. Number 6, there is a 3, 4, 5 what? 3, 4, 5 angle. Number 6. 3, 4, 5 triangle. So you have a 3 kilogram object is moving down on 3 meter tall building, which has a ramp 5 meter. All right, x-axis 4 meter. Okay, this triangle is 3, 4, 5. Now this one must be smaller, and this one must be bigger. This one is by default 90 because this is a right angle. Okay, now let's see. This is wood on wood. Wood on wood by definition, mu k is 0.3. Right now, first of all, we're going to be talking about what is energy at location A. Well, very simple. Energy at location A is potential energy, gravitational potential energy is mgh, right? Okay, so we can say gravitational potential energy at location A, which is equal to wg parallel. They are the same. So mgh is equal to wg parallel is what? Mg sine theta d. All right, so this is 3, this is 10, this is 3. This is 3, this is 10, this is sine 37, and this is d, this is 5. So this is 90, this is 90. What is 90? Kinetic potential energy over here is 90. All the potential energy convert to kinetic energy, and then finally convert to nothing, 0. At some point, this is gonna be velocity gonna be, instead of increasing, velocity gonna be 0. Now let's see. We're gonna use the force diagram for this one. So what are the forces responsible for this one to move from A to B? Only one force, and that is what? FG parallel. And how many factors involved into slowing it down? Only one. What is it? FF. That's it. So now, okay. So at right here we have 50, we have 90. Okay. By the time it gets here is not gonna be 90. How much? Okay, that's what we're gonna find. Let's start with Newton's second law. Newton's second law is F equal ma. So how many F? 2 FG parallel minus FF. Which one is positive, which is negative? Bigger one is always positive. Smaller one is always negative. So M is how much? M is M plus A. Okay. So MA. I'm so tired. I was actually falling asleep while solving the problem. Because it has been a long day. So FG parallel. So MG, check my math. Probably I don't know how many mistakes I've been making. Sine theta. Okay, mg sine theta minus mu mg cosine theta is equal to ma. M cancel. So acceleration is g sine theta. Again, you make the bigger one positive and smaller one negative, minus mu g cosine theta. All right, so acceleration is 10 sine 30, 37 minus mu, which is wood on wood, so 0.3, 10 cosine 37. Cosine 37. So acceleration is 3.6. Right now, what we need to find, work done by net. All right, so F D, whatever F net. How can we find the net? MA D. What is M? 3. What is A? 3.6. And what is D? Okay. 5. So this is 154. All right, great. Joule. All right, now we are not even halfway, and I'm pretty tired. Number 7. Number 7 is So number 7 is when I said I'm going to finish it in 14 minutes, maybe it's going to take a little bit more than 14 minutes. Number 7, you have a granite, you have a 10 kilogram granite, and it's moving at a direction showing 10 meters per second. What is the momentum at that direction? 0. What is momentum at the y direction? 10 times 10, 100 kilogram meter per second. Now, what do? You throw the grenade in the air, and it broke into 2 pieces. This is 5 kilogram and moves to 5 meters per second, and this is 5 kilogram move to different direction based on the information you give. So 5 meters per second. Okay. No, no, we don't know. We don't know this one. Okay, we don't know this one. That's what we're gonna find, and we also find the angle. Most importantly, we're gonna find the angle. Okay, so how? Let's say x and y. X and y. What is it? Px is equal to m1 v1x plus m2 v2x, and this one is py is equal to m1 v1y plus m2 v2y. So this one is of course 0. Why is that? Because 0 momentum is 0 before collision. Okay, m1 is 5, v1x is 5 plus m2 is also 5. V2x we don't know this one. Okay, so v2x. So v2x is equal to what? Um, 25. Okay, -5. So this one, m1. Well, this one is given 100. This one is m1 v1y plus m2 v2y, and this one is 0, right? Which one is 0? At the y direction, this one is 0. At the y direction, momentum is 0. At the x direction, momentum is 25. Okay, good. Now, so this is 100 is equal to, this is 0. This is m2. M2 is 5. So 5 v2y. So v2y is 20. Okay, great. Now, what are you going to do? You're going to find the angle of this one. So theta is equal to tangent inverse y over x. So theta is equal to tangent inverse 20 over not 20. Y is 20. Yeah, is -5. Wow. So theta is equal to -4. Okay. So what I like is this one. This one is -76. However, that's not the answer. That's probably going to calculate and give you. So now, if this one is -76, this one must be 104. Okay, so that takes us the last multiple choice question, which is number 8. There is a negative charge here, and there is a point P over here, right? Okay, so what would be the direction of the electric field at location P? Let's give you some sample. This is 1, this is 2, this is 3, and this is 4. Which one would be the electric field at location P? Well, of course, this one. Not this one, not this one, not this one. Okay, good. Now, why? It's because negative charge field always inward. Let's next test. What I'm going to probably give you is this one. The field decreases as what happened? Distance increases. So I'm going to draw same thing over here, and I'm going to draw same thing over here as well. I'm going to probably give you some information. This is 1 nanocoulomb. Of course, this is negative. Let's say this is 0. This is 1 meter. This is 2 meters. This is -1 meter. This is -2 meter. I want you to find the size of E1, the size of E2, the size of E3, and the size of E4. Okay, very simple. E3 would be 9 Newton over Coulomb. E4 would be 9 over 4 Newton over Coulomb. This is also 9. I'm talking about the magnitude. You already have the direction. Newton over Coulomb, and this is 9 over 4 Newton over Coulomb. Why it is 9? Well, E is equal to K, Q over R square. K is 9 times 10 raised to 9. Q is 1 times 10 raised to negative 9. Distance is 1 square. So this is 9. And since you double the distance, so it gets smaller by 4 times. That's Coulomb's law. Let's go over problem number 9. Problem 9 is, let's say you drop something, right? And the reaction time we're going to find based on where you can catch the ruler, and you catch the ruler at 20 centimeters. So VIT plus half AT squared. Since you drop it at the y direction, we have to use the D is equal to VAT plus half AT squared at the y direction. When you drop something, your initial velocity is 0. Good. All right, so this is what? This is negative 0.2. This is minus 5 t squared, because acceleration due to gravity we are using negative 10. So t is equal to 0.2 second. All right, now with this reaction time, would you be able to save someone's life? Okay, let's see. To save someone's life is a good thing. You are at location A. What is the distance? 0 with respect to location A. The distance is 0. Time is 0. Velocity is 20 meters per second. Acceleration is 0 because you're moving with constant velocity. Okay, that's pretty much it. At location C, you see a man walking. What does that mean? There is a distance from your car to C, and that is, let's say, 20 meters. That means if you really try, you would be able to save the person's life, because 20 meters is more than 0 meters. If it is like 0 meter distance or 2 meter distance or 3 meter distance, it would be impossible. 20 meters, I think, is long enough. Okay, good. However, it takes you almost 0.2 second for you to react. So you react over here. What does that mean? You react at 2 seconds, 0.2 second. Okay, so it takes you that long to react. Okay, so velocity is still 20, because velocity gonna go down 19 after the reaction, not at the reaction. How do you react? By hitting the brake, which is acceleration. Now let's find from 0 meter to what? Okay, and that is, of course, VAT. Half AT squared I'm not going to write, because this is x direction. Y direction, there is acceleration. X direction, there is none. 20 times 0.2, so 4 meters. Okay, so now we want to find his, we want to find x. Okay, what is x? X could be here, or x could be here. In the test I use D. People usually think D comes after C, so there is no happy ending. Okay, then you don't have to think about D comes after C. You can think x. X is unknown for algebra. Okay, most cases. All right, x could be here, x could be here. If x is here, you have a happy ending. If x is here, you don't have a happy ending, regardless. Put the C over here so I have more room. Okay, so this is okay, good. Well, let's say x is here. All right, so what does that mean? You have to find, not this one, of course, you have to find this one, because this one you already found. How can you find this one? VF squared is equal to VI squared plus 2AD. So this is Vx squared is equal to VB squared plus 2ABD. This is Vx squared, all right, which is 0. Why? At x, your velocity, you stop the car over here, and velocity is 0. Okay, good. VB squared, you have 20 squared plus 2 negative 20 D. So D is equal to 10. All right. So if over here, from here to here is 10 meters, from here to here is 14 meters. And 14 meter is less than, of course, 20 meter. 14 meter is less than, 14 meter is less than 20 meter. From here to here is 20 meter. Okay, so what does that mean? That means the car was initially at here, the person was initially at here, C, and the car stops, and here to here is 20 meter, and the car stops right here, that's it, it stops, and here to here is 14 meter. Okay, let's go to problem number 12. Problem 12. Okay, so 12. Problem 12, let's say we have 3, let's consider 3, 4, 5. Right. Let's call it 3, let's call it 4, this looks longer, this is called 5. If this is 3 and this is 4, this must be 53, this must be 37. We're going to call this one is Q1. Let's call it negative, and this is Q2. Let's call it positive. Let's call, and let's find the electric field over here. Okay, good. All right, so let's call it, I don't know, 25, negative 25, and let's call it 16. We're going to call it, all right, let me see what value I gave you. I gave you a negative 25 nanocoulombs and 16 nanocoulombs. So 10 raised to negative 9, 10 raised to negative 9 coulomb. Good. All right, at location E, we have to find the electric field. This is E1. Why this is E1? Because inward, right? If you are negative, then you create the field like this, right? And one of them gonna look like this one. Okay, good. So inward because negative. All right, great. And E2 outward. Why outward? Is because positive charge create a field outward. So this is E2. All right, so let's find E1. To find E1, we're going to use Ka Q1 over R squared. K is 9 times 10 raised to 9. Q1 is 25 times 10 raised to negative 9. And divide by 5 squared. So 5 squared, 25 cancel. Negative 9, positive 9 cancel. So this is 9 Newton over Coulomb. Let's do E2. KQ2 over R squared. So 9 times 10 raised to 9. You have 16 times 10 raised to negative 9. And you have 4 squared. So 4 squared, 16 cancel. 9, 9 cancel. This is 9 Newton over Coulomb. Good. We have to find the E. There are multiple ways of trying to find E. We're going to explore 3 ways. One is parallelogram, one is vector addition, and one is law of cosine. Let's do parallelogram. Parallelogram. Parallelogram, what angle we use? Angle between E1 and E2. We call it angle between vectors. We have 2 vectors. What are they? E2 and E1. What are the angle between these 2 vectors? Well, let's see. This is 37, this must be 53, this is 90, 90 plus 53, 143. So this is 143. Great. So what is the equation? E is equal to E1 square plus E2 square plus 2E1 E2 cosine 143. So E is equal to 9 square plus 9 square plus 299 cosine 143. E is equal to 5.7 Newton over Coulomb. If you use law of cosine, you use angle between head and tail. Head and tail. Okay, what is the angle between head and tail? Let's check it out. Okay, so let's do this one. Let's create parallelogram. Is this head? Yes. Is this tail? Yes. So this angle 37 is the head and tail. So law of parallelogram tells us that E is equal to E1 squared plus E2 squared plus negative, be careful, to E1, E2 over cosine, of course, 37. So E is equal to 9 square plus 9 square plus 2 times 9 cosine 37. So E is equal to, of course, 5.7 Newton over Coulomb. Now vector addition, you can do the vector addition finally. If you do vector addition, let's make a room. Vector addition, you have E, E1, E2, E1x, E1y, E2x, E2y, 9 cosine 307. Why 307? You have to use x-axis counterclockwise. 9 sine 307. 9 cosine 90. 9 sine 90. This is 5.4. This is negative 7.2. This is negative 7.2. This is 0 and this is 9. X plus x is 5.4. Y plus y is 1.8. Convert this one to a vector. Convert this one to a vector. Okay. Use the Pythagorean theorem. 5.4 squared plus 1.8 squared. And that is 5.7. Convert 5.7 to a vector. 5.7. All right. Newton over Coulomb. Great. This was problem number 12. Let's go over problem 13. Just to remind myself, problem 13 is, okay, well, that was problem 10 actually. So let's go over problem 11. Starting from, okay. So problem 11 is, mechanical energy. What does that mean? Say you have height. Let's say height is, let's say how much height is. Height is 1.5 meter. And let's say you have a ramp. Or maybe a road like this. It doesn't have to be ramp. Okay. All right. So the road is, well, yeah, could be anything. So there is a mass over here. Mass is 40 kilogram. The person is moving with constant acceleration, 0.3 meter per second square. All right. And the ramp has a size. Ramp is 4.2 meter. Ramp is 4.2 meter. Okay. All right. Now, what do you want to find? The mechanical energy lost. What do we know about location A and location B? Location A, we have a potential energy. We have a kinetic energy. All right. So we have potential energy, kinetic energy is 0. So we have a mechanical energy, which is 100%. We're going to replace 100% by whatever it is. Location B, we have a potential energy, which is 0. Kinetic energy, which is probably not 100%. We don't know whether there is a friction, but let's write kinetic energy. Both of them is mechanical energy. And mechanical energy, if this mechanical energy equals this by 100% over here, then we will say that no mechanical energy lost. But let's investigate. Okay. Investigation, we will start with potential energy over here is 100%. The person is 40 kilogram. Gravity is 10. Height is 1.5. So potential energy at location A is 600 joule. So you're going to write 600 joule. You assume that kinetic energy over here is 600. So mechanical energy over here is 600. This is just your assumption. You don't know. You have to do investigation. So let's keep doing investigation. One thing you know that the person is sliding with some acceleration. Vf squared is equal to Vi squared plus 2AD. So VA squared is equal to VB squared plus 2AD. VA squared is 0. Why? Kinetic energy is 0, so velocity must be 0. BB squared plus 2 times acceleration is 0.3, D is 4.2. So VB is 1.6. And 1.6 is going to help you find the kinetic energy over here. If it is 600, then you lost 0 mechanical energy. Okay. So now let's see, kinetic energy is half mv squared. So kinetic energy is half, m is 40, v is 1.6 squared. So kinetic energy is 20 times 1.6 squared. So kinetic energy is 51 or just 50. All right. So kinetic energy is 50. Oh, God. All right. So mechanical energy is 50. Jesus. All right. Not even close. So what are you going to write? Mechanical energy lost. Mechanical energy lost is equal to mechanical energy at location A minus mechanical energy at location B. You always use the small one and big one always positive. So mechanical energy lost is equal to 600 minus 50. So mechanical energy lost is equal to 550. Almost all mechanical energy lost. Why is that? There is an object with 2 kilogram moves with 2 meter per second squared to the right, has applied force and has force of friction. Now, force of friction is given 2 Newton. I want you to find the work done by net force. Okay. Okay, work done by net force meaning F net is equal to ma. So F net is equal to m is 2, a is 2. So F net is equal to 4 Newton. Okay, so work done by net force is equal to net force times d. So work done by net force is equal to net force is 4 Newton and d is 2 meter. So work net is 8 joule. Okay, great. And that takes us problem number 13. Problem number 13 has to do with also right, 3, 4, 5 triangle. So 3, 4, 5 triangle. Okay, I don't know which one is bigger. Let's make the y is really big, look like big. Okay, now y looks like bigger than x, so I make x3 makes y4. This one looks bigger than everything, so this one is 5. So this one is 53. This one is 37. This one is 90. This is q1. This is q2, and this is q3. q3 is 25,000 times 10 raised to negative 6 coulomb, and this is I don't know, this is, let's say I gave you so no worries, I'm going to write it down. So q2 is 16 microcoulomb, 16 times 10 raised to negative 6, and then the other one is 25 microcoulomb, and then this one is 10 microcoulomb. 10 times 10 raised to negative 6. What I ask you to find at location at Q3, I ask you to find the E, no, F. So this is F1. Why is that? Because positive and negative attract. And this is F2Y because positive and positive repel. Okay, great. So fast thing fast, we're going to find F31. So this is F31. What is F31? This is 3, this is 1. K Q3 Q1 over R squared. So K is 9 times 10 raised to 9. Q3 is 10 times 10 raised to negative 6. And then this one is 25,000 times 10 raised to negative 6. All divided by, you have 25. So 25, 25 cancel. So you have F31 is equal to 9 times 10 raised to 9 times negative 5, negative 3. Okay, so that means 90 Newton. Okay, now we're going to do F32. F32 would be what? K Q3 Q2 over R squared. So 9 times 10 raised to 9. Q3 would be what? 25,000 times 10 raised to negative 6. Q2 would be 16 times 10 raised to negative 6 divided by what? 16 cancel. F32 is 9 times 25 is 2225 times 10 raised to 9 minus 3 minus 6. So this one cancel. So F32 is 225 Newton. All right. So we have we can use the only one way because I show you using multiple way before, so you know how to do that. If this is 37, this is 53, this is 90, so this is 143. So you're going to use law of parallelogram. We are finding f, which is f1 f31 squared plus f32 squared plus 2 f31 f32 cosine 143. So f is equal to f31 is 90 squared plus 225 squared plus 290 225 cosine 143. So f is 162 Newton. Okay, that takes us last problem 14. Problem 14, I gave you Q2, this is 100, Q1, which is 1 microcoulomb, 100 microcoulomb. Okay, and there is a distance between these two, and let's call it 22 meter. Is that right? 22 meter, right? Yeah, 22 meter. Yeah, was it 1 and then 22 meter, and Q2 is 100. Okay, right. Put Q3 here. All of them positive. So this one, 3. This is Q1. All right. So 31 should be this way, and 32 should be this way. Why is that? 3 and 2 repel. 3 and 1 repel. So you're going to write F31 is equal to F32. F31 is equal to F32. So K Q3 Q1 over R squared is equal to K Q3 Q2 over R squared. K Q3 K Q3 cancel. So you have Q1 over R squared and you have Q2 over R squared. All right, you cannot cancel them, by the way. So Q1, which is Q1, Q1 is 1. So 1 over R squared, let's call it X. Here is X squared is equal to Q2. 10 raised to negative 6, 10 raised to negative 6 cancel. So this is just 100. Q2 is 100 over 22 minus X squared. Okay, so you're going to square root both sides. So this is 1 over X. Then this is 10 over 22 minus X. So 10X is equal to 22 minus X. What does that mean? Well, being this one, 11X is equal to 22. So X is equal to 2. All right, so that was your exam number 14. Last exam, MP4, last exam gonna be next week, Friday, April 4. Hopefully everybody gonna end happy. It's gonna be happy ending. Everybody gonna get 100. So make sure you study these materials. I'll see you on Tuesday.